In this lesson, we're going to learn about some basics about polynomials and how to add and subtract them. So polynomials are named according to their degree and number of terms. So to name a polynomial by degree, it's the degree that is the largest exponent of that particular variable. So if the degree is 0, we would call it a constant. An example of a constant polynomial would just be a number with no variable attached. When it's degree 1, we would call it linear. An example of that would be maybe 5x, and that's really 5x to the first power, so that's what we're talking about in terms of the degree. The degree has to do with the exponent. All right, the degree 2, we would call that a quadratic. So that would be something like 5x squared. So these examples that I'm giving are just kind of the most basic type polynomial with just one single term. Degree 3, we would call that a cubic polynomial. So it would be maybe 5x to the third power. Degree 4, we would call it a quartic polynomial, so that might be 5x to the fourth power. Degree 5, we would say quintic, and that would be maybe 5x to the fifth power. And then everything 6 and up, we would say just the nth degree. So for example, 5x to the sixth power, that would just be a 6th degree polynomial. Okay, the other way we name a polynomial is based on the number of terms. So the way I like to think about it is that the degree is like the first name and the number of terms is the last name. So by the number of terms, the way you can identify terms are separated by addition and subtraction signs. So if there's only one term, we call it a monomial. Mono meaning 1. So that might be 5x squared. That's just one single term. Two-term polynomial is called a binomial. So that might be 5x cubed plus 3. So there's two terms here, term 1 and term 2, separated by an addition sign. A 3-term polynomial is called a trinomial. So that might be 5x to the fourth plus 2x minus 4. So 3 terms, 1, 2, 3. And anything 4 and up, we would just call a polynomial. So for instance, we have negative 6x to the 6th plus 3x to the fourth minus 3x plus 1. That's 4 terms, 1, 2, 3, 4. We would just call that a polynomial. All right, so let's practice just naming some polynomials. So we have negative 7 plus 3n cubed. So the highest degree exponent is 3, which would make it cubic. And since there are 2 terms, it would be a cubic binomial. For the next one, there's no variable, no exponent, which would make it a constant term. And since there's only one term, it would be a constant monomial. The next one, the highest degree exponent is the fourth power, which would make it a quartic. And then in terms of number of terms, we have 1, 2, 3, so it would be a quartic trinomial. All right, so now let's talk about how to write a polynomial in standard form. So to write a polynomial in standard form, we arrange the terms so that the term with the highest degree exponent goes first. Then what we do is we follow with the other terms with exponents in decreasing order, so from highest to lowest. And then the last term should be the constant term if there is one. All right, so looking at this polynomial here, we have negative 5x plus 3x squared minus 12 plus x cubed. So the highest degree exponent I see is the x cubed term, so that's going to go first. Then the next term is going to be the x squared term. And then the next term is the x term. And then we have our constant term. So that's the order that we're going to write it in. So writing this in standard form, we have x cubed plus 3x squared minus 5x minus 12. So the important thing to remember when you're rearranging these, you need to make sure that the sign goes with the number. So for instance, this term isn't just 12, it's actually negative 12. So when you write it in standard form, you need to make sure you write minus 12. All right, the next section, we're talking about adding and subtracting polynomials. So what you need to know in order to add and subtract polynomials is what is considered a like term. A like term is a polynomial with the same variable and the same exponent. So for example, 2x squared and 5x squared are like terms because they're both x squared terms. Same thing when there's two variables, xy squared and xy squared. These are both like terms because the y is squared and the x is not. So some non-examples, 3x to the fourth and negative 5x squared are not like terms because even though they're the same variable, the exponents are actually different. Likewise, on the second one, x squared y and xy squared are not like terms because in order for them to be like terms, even though they have the same variable, they have to have the same exponent. All right, so once you've identified like terms, all you need to do to combine them is you just add the coefficients. Okay, so let's look at an example here. We have two polynomials. So yes, they're written in parentheses. I know a lot of people, when they see parentheses, they automatically think multiplication, but you have to look at the symbol between the two parentheses. If there is no symbol, then yes, it is multiplication, but since there's a plus sign between the two parentheses, that means we're going to be adding the two polynomials. So the parentheses are just acting as a grouping mechanism. All right. So when adding polynomials, there's two things you need to remember. The variables are not going to change. The only thing that changes when adding are the coefficients. So the variables do not change. Okay, the other thing we need to remember is that when we're adding, you're basically going to ignore the parentheses. All right, so looking at this example, what we're going to do first is identify like terms. So I have a negative 2x squared term and I have a 5x squared. Those are like terms because they're both x squared. And then I have a 3x and a negative 4x. And then lastly, I have a negative 7 and a negative 8. So now we're just going to add the coefficients. So negative 2 plus 5 is 3, so it's going to be 3x squared. So remember, the variable and exponent don't change. All we're looking at are the coefficients. So we're just looking at the numbers out in front. The next pair of like terms, I have 3x and negative 4x. So 3 plus negative 4 is negative 1x, or you could just write minus x. And then lastly, I have a negative 7, my constant term, and negative 8. So when we combine those together, we get negative 15, so minus 15. And if you notice, when I was writing this, I went ahead and started with the highest degree exponent so I could write it in standard form without having to rewrite it. So that's written in standard form. We can box it. That's our final answer. So remember that this 3x squared is coming from the negative 2x squared plus the 5x squared. The negative x is coming from the 3x plus the negative 4x. And this negative 15 is coming from the negative 7 plus the negative 8. All right, so now what about subtracting? So in order to subtract polynomials, what you're going to do is you're going to distribute the negative first. So we're going to take this parentheses and distribute it to every term on the inside. So when you multiply something by a negative or negative 1, what it essentially does is it flips the sign of these parentheses. The first parenthesis stays the same, negative 2x squared plus 3x minus 7, but the second parentheses, the signs are going to flip. So it was a 5x squared, so now it's minus 5x squared. It was a negative 4x, but now it's plus 4x. And it was negative 8, so now it's plus 8. So once you do that, now we can identify our like terms. So I have a negative 2x squared, negative 5x squared. I have a 3x and a negative 4x, and a positive 4x, and a negative 7 and a positive 8. So combining like terms, negative 2 plus negative 5 is negative 7. So that's going to be negative 7x squared. And then I have a 3x and a 4x, so that's plus 7x. And then I have a negative 7 and positive 8, which is going to be positive 1. So this first term is coming from the negative 2x squared plus the negative 5x squared. The second term is coming from the 3x plus the 4x. And this last term is coming from the negative 7 plus 8. So when subtracting, you're going to distribute the negative, which essentially flips the signs. And then remember that the first parentheses stays the same. All right, so now let's do a couple of these you-try problems. So number 1, we're adding, so we're just going to ignore the parentheses. I'm just going to identify like terms. I have an x squared term and an x squared term here. Then I have an x term and an x term, and then I have my constant term. All right, so then combining like terms, I have 5 and 2, that's 7x squared. Negative 3x and positive 5x, that's positive 2x. And then a 7 and a negative 15 gives me negative 8. Okay, the second one we're subtracting, so we're going to first distribute that negative, which is going to flip the signs of the second parentheses. The first parentheses stays the same. So it's minus 7x squared minus 8x, and now we can identify our like terms. We have an x squared here, an x, and then we have our constant term. So negative 3 and negative 7 is negative 10x squared. 4x and negative 8x is going to be negative 4x, and then we have just a negative 9. All right, now I'm going to go over a couple of the practice problems. It's pretty straightforward. I'm just going to do one adding and one subtracting. So if you notice, these are not written in standard form, which means after you identify the like terms, you need to just make sure you write it in standard form. So when looking for like terms, start with the highest degree exponent. So we have an x to the 4th term, and scanning through the rest of the terms, there are no other x to the 4th terms. So we're just going to write that down, negative 8x to the 4th. Okay, next one, the next highest degree is going to be an x squared term. There are no other x squared terms, so that's going to be plus 4x squared. The next one is the x terms. So we have 4x and negative 3x, so that's going to be plus 1x, or just x. And then lastly, we have our constant terms. So 6 and 8, which makes positive 14. So if you do it this way, your polynomial is already going to be written in standard form. You don't have to worry about rewriting it. All right, number 7, we're subtracting. So first thing we're going to do is we're going to distribute that negative to all the terms. So the first parenthesis stays the same. Second parenthesis becomes negative 7x cubed minus x to the 4th minus x squared. Okay, now we're going to combine like terms. So looking for the highest degree, x to the 4th is the highest. And we have x to the 4th and negative x to the 4th. So those terms actually just cancel out. Next highest degree is we have x cubed. So 3x cubed and negative 7x cubed. So that's going to be negative 4x cubed. And then we have our x term, or our x squared terms. And that's the only x squared term, so minus x squared. And then lastly, I have my x term, which I only have one of, so it's just going to be plus 4x.